Hello everyone, for the lab of today you have subnetting as well as how you can have the messages transfer from one network to another, and this is done via IPs. And in this case you will be using IPs of version 4, meaning that in fact you have 4 octets, and this means that you have 4 multiplied by 8, meaning that you have in total 32 bits. So you will have a sequence of values of 0 and 1, such that every octet which characterizes an IP address will be converted into decimal. Okay. So keep in mind that every bit uses the power of 2. As you can see here, okay, we have, you start from this side. Okay, this is 2 to the power 0. So it means that you have in fact 8 bits, and you start numbering from 0 until 7. So meaning that here the leftmost is 2 to the power 7. Then you have 2 to the power 6, 2 to the power 5, 2 to the power 4, 3, 2, and 2 or 1. And as you can see here, okay, you have the equivalent when doing the sum of being this one with 255. Okay, so this is why you were adding the mask with 255, the 255, and 255, meaning that you use all the bits which characterize a certain octet. So let's see. Now, when having an IP and you have it in decimal form, you wanted to convert it into binary, meaning that 10 needs to use the greatest power of 2, which is less than 10, meaning that you have the sum between 8, which is on this position, and 2. Okay, then 1 is just here. 23 is the power of what, which is the greatest power of 2 that you need to use, such that you can represent 23. It would be this 16, no? Because 32 is greater than 23. Then what would you add? If you add 8, you have 24, which is greater, so you don't need to use it. Then you need to use 4, 2, and 1. And this is why you have these ones on these positions. Then 19 is what? The greatest power of 2, which is less than 19, is 16. So you use this 16. And keep in mind that 16 is the 4th position from left to right. So this is why you have it here. Okay. Then what you need to add is, can you add 8? No, I would obtain 24. If I add 4, I would obtain 20, which is greater than 19. So I need another 2 and the 1 in order to achieve this value of 19. So this is what we need to do for this part until now. Is it clear to everybody until this point? So every octet is split in fact into 8 bits, and you need to use the powers of 2, knowing that position 0 is the one placed here, the rightmost position. Okay? And you have 2 to the power 7 being the leftmost. And you have 2 to the power 7, which is the equivalent of 128. 2 to the power 6 is 64. And here you have 2 to the power 0, which is 1. After that, for every IP that you've got, you can transform it into binary, okay, according to the powers of 2 that you can use such that you can represent the number. Then you see here that you have the classes. So this is what you were doing according to the IP, and it was even providing the mask for you. This means that for every class, you've got the network part, like here for class A, you need to have this mask of 8, meaning that you use the first 8 bits to represent the network, and the remaining 24 bits are used for your stations. Okay, so here you have stations. Okay. Now, when I want to assign all these addresses that exist, or the IPs of version 4, meaning that you have these 4 octets, you need to start from 1000. And as you can see, the following B class, it will use the first 2 octets. So you have the mask of 16, meaning that you have these 16 bits for your stations. Okay. And here you see that you have 128, which is in fact 2 to the power 7, okay, which is used, such that you have the end of class A ending in the previous address. And which is the previous address? Well, you have this 127, and you need to fill in all the other octets with the maximum value which you can have, which is 255. You have 255 3 times. Then you have the following one. Let's see. Here for class C, in fact, you will have the mask of 24. Okay, which is the network, and you have 8 bits for the station. Okay, so this is your ST. As you can see here, in order to obtain 192, what you need to add is 64. So it means that you need to add the power of 2 to the power 6. Okay, and this is equal to 64. Okay. Such that I obtain 192, but which is the IP, which is the ending of this interval? Well, it is like having the open interval here for 192. So it means that the last value is this 191, okay? And you have the remaining octets being filled, okay, with 255, 255, 255. Then we have the multicasting, that it will transfer your packages towards multiple destinations. And this means that 192, you need to add what? You need to add to the power 5, which is equal to how much? It would be 32. Okay, and this means that you obtain here at the starting point 224, meaning that you need to end in this value where you have 223. And as before, you have the last 3 octets that are filled. Also, afterwards, you need to add to the power 4, which is equal to 60. And in this case, you would obtain 240, and you have the 0, 0, 0. So everything starts, as you can see, with 0, 0, 0. It ends in 255. Okay, so having it, you need also to end it in 255, but it will be the value that is placed before, such that we have this 239. Okay, which would be the next value that should be added here. Okay, we have here how much? You see that it ends exactly before, so it would be until the end of your interval. Okay, so it ends in 254, so 255, 255, and 255. So it will not reach that 255,000, okay, which is the maximum capacity. Right. Okay. Do you have any questions up to now? Have some problems or misunderstandings? So for class A, you need the first octet for network, the remaining 24 bits for stations. Class B, 16 bits for the network, 16 bits for stations. And class C that you will be using, you have 24 bits for network and the rest are for the stations. So in fact, here you will have all these IPs with mask 8, 16, and 24. And the others have a multicast property. Okay. Here we have the multicasting as well as ease for future use. So you won't be applying it. Okay. Now let's see how many stations you've got. So it means here that for class A, okay, as you can see, so to have so this is the class A. You see here that you have all these 24 bits, okay, which can be used for the stations. So this means that you have 2 to power 24, okay, minus 2 stations because you don't use the network and the broadcast address. The network is the one which defines the entrance point, okay, inside your local area network, as well as you have the broadcasting address to send messages towards all the other stations from other local area networks or plans. Okay, so here you have, in fact, for these stations, you have 2 to power 24, okay, minus 2, meaning that similarly, here you have also 2 to power, okay, you have this 16 minus 2, all right, so you will have them, as well this 8 would be 2 to power 8 minus 2. Okay. So here for class C, you have 2 to power 8 minus 2, which is 256 minus 2, so it's equal to 254 stations that you can have in your local area network. Any questions regarding this part? So it's always you use the number of bits for your stations. Class B is 2 to power 16 minus 2. Then class C is 2 to power 8 minus 2. And you would obtain the final number of stations, the maximum number of stations that you can have. Okay. Now, in this case, you see that for every mask, you can write it in that 8, but it means how many octets you use. So in fact, class A with this mask of 8 means that you have this one with 255,000. Okay, so you use just the first octet. Class B is when you use the first 2 octets. So this is why you have 2 times at 255 and with 00, as well as we have class C, which uses 24 bits, such that you've got the first 3 octets occupied. Then, when you have an IP of class A as well as the associated mask, you can transform it into decimal. Let's see here. This means that 8, you need to use 2 to power 3. So you have the fourth bit from right to left. Okay, so it means that you need to use this one. 20 is the sum between what? You have 16 and 4. So this is why you need to add these ones. Okay. 15 is what? It's not 16, it is, you have the remaining bits, so exactly this one, and one is placed over here. While the mask with this 255 means that in fact you have this octet of ones. Okay, so this is how you write it in binary. So you convert from decimal to binary. Then based on it, you see that here at the beginning you've got the network, such that being of class A, the network ID is 8, and the host ID is this one with 20, 15, 1, and the mask occupies just the first part of the network. So it's until here, such that you know where you have the network ID. Okay. Let's see. Then you have the network address. So the network address characterizes your local area network, and this is when you perform the logical AND between them. Okay. Let's see. Now, if I want to obtain my network address, this means that I do the logical AND based on the bits. Okay. How much would I obtain? Here, which would be the resulting value?
Which ones?
So based on this one, okay, so what would you obtain? A 0, a 1?
255.
Based on the logical AND?
Oh, sorry,
For the
8.
logical AND? Yeah, exactly. So this one would be 8. Then what would you have? 0 and no matter what is how much?
0, all of them.
Yeah, exactly. So you have the 0, another 0, and this one. Okay. Then this means that you have the entrance, okay, for your network, as well as you have the broadcast address, okay, in order to deliver the messages towards all your hosts. It means that you need to do the logical OR, but you also need to invert the bits regarding the mask. So it's in fact a NOR. You also invert as well as you do the logical OR. So now we have this broadcast. Okay, so you have the NOR, you invert the mask, and you perform the logical OR. Such that here, let's see, for broadcast. Here it means that for the mask I have 0 up to here, and then I have a sequence of 1 until the end. And now between the two of them, I need to perform the logical OR. Okay, so let's see. For the logical AND, whether it's 0, 1, where 0 is false, 1 is true, and you have another 0 and 1. Okay, it is true when both arguments are true. For the others, it is false. Okay. For the OR, okay, it means that we have 0, 1. Okay, then you have again a 0 and a 1. Here we have 0, and if you have one argument which is true, then everything is true. Okay, so here is just the corner, and here we have these sides. All right, so which would be the value for broadcast if I do the logical OR between this mask with 0 here at the beginning of the octet, and then I have just 1 until
8
the end.
and 255 until the end.
Exactly. Yeah, exactly. Okay, writing. Okay. So this is how you compute the beginning and the end of your network. Okay. Such that for the network address you perform the logical AND between your network and the mask. Okay. And for your broadcast you need to invert firstly the mask, after which you perform the logical OR. Clear for everyone? You will still not escape. Okay, so let's see. The first address which you can assign here would be the one following the network. So the first address, okay, will be in fact which one? Based on 8. You have 8 and then you have a 0, 0, 1. So you start filling the values starting with the rightmost octet and the last, okay, y, will be the one with 254 at the end. So it means that we have 8, 255. Okay, again a 255. 254. Okay, so these are the addresses that you can assign for your stations inside the network. Okay, and you start adding here a 1 at the end, while here for the last address you need to subtract 1. Okay. Then you think like this. You can choose your mask, so you can have a mask which remains the same. And this is according to the address space which you've got. So this address space is in fact the mask according to your class. So whether it's of class A, the mask is 8. Whether it's B, you have 16 because you use 16 bits for the network. And whether it's the class C, you have 24 because you use 24 bits for the network. Then you will have the number of subnetworks, which is n. And based on it, I want to see how many bits do I need for this number of networks, such that my n should be less or equal than 2 to a power n. And based on this n, my new mask would be the initial one plus the number of bits that I need to have in order to exist this number, uppercase n, of subnets. Also, we need to think how many stations can you have. So the bits that remain out of the 32 bits which you can have for an IP are the 32 minus the mask, which you have by default, and minus the bits which you did receive according to the number of subnets. Then, based on this P, how many stations can you have? Well, you have in fact 2 to power P, minus the network address, which the broadcast address being the addresses which you cannot assign for your stations. So let's see here. Okay, you have this network, and this network you have firstly 120 stations here, 60 stations here, 50 stations here, as well as you've seen in Cisco Packet Tracer, you also assign IPs for these ports between the routers. So here you've got another network, such that in fact you have 4 subnets, 1, 2, 3, and the connection between the routers. And for this one, you have this address space that is known. So it's 192, where 192 is the sum between 128 and 64. Okay. 168 is what? It's 128. Then you need to use 32 as well as you need to use this value of 8. 30, okay, you need to represent each and every one of them in the same manner. Okay, according to the powers of 2. Then let's see. You have this network, and now I want to use the fixed net. Okay. You have the number of subnets which needs to be less or equal than 2 to the power n. So it means that I have 4 subnets, 1, 2, 3, 4, which is less or equal than 2 to the power n, meaning that I have 2 bits. Okay, so if I look at this one, and the fixed next mask, okay, let's have it here. Okay. And this one. Okay. All right. So based on it, which is your mask that you have here? As you can see, the default mask, so my M in this case, okay, is equal to 23. Okay, so based on the default mask which is given. Keep in mind that it can be tricky. This 192 belongs to class C, so it would be 24. So this is why you need to pay attention. And in fact, you need to choose your M as being 23. Then you've got the number of subnets. Okay, so let's look here. The number of subnets is 1, 2, 3, 4. So my uppercase N will be equal to 4. Then I need to find out which is this n such that 4 is less or equal than 2 to the power n. Okay, meaning that my lowercase n is equal to 2. Okay, such that which is my new mask? So my new mask will be the previous one, which is this 23. Okay, based on which I need to add 2. So it would be of 25. Okay. How many bits remain? Well, this P will be my 32. Okay, then I need to subtract how much? The default mask, which is 23, minus the bits for representing the number of subnets, which is 2. And this is equal to how much? 32 minus 25
7.
gives you 7. Yeah. So in fact, you can have in total maximum 2 to the power 7 minus 2 stations because you cannot assign the network and the broadcast address where 2 to the power 7 is how much? It's 128. 128 minus 2 is 126. Okay, 1 to 6 stations. Okay. Clear until here?
Yes.
Okay. So I will paste it over here and let's see. Now what you need to do is that you have to assign addresses. Okay, let's make it big and drawing it. Okay, I have a fixed mask and my new mask is this 25. Okay, so every time for my bits I need to add what? 2 to the power 7. So as you can see, based on this last octet, I need to add 2 to the power 7 to have all my stations, including the network and the broadcast address. So this is why I obtained this value of 128, meaning that the end of the previous network ends in 127. And in fact, from 0 until 127, I do have 128 stations. And also the mask for all the networks which you've got remains 25. So this is the one with the fixed mask. No matter how many stations you use, you have a fixed mask. And this is exactly, you have your IP in binary. Okay. So you would represent each and every network according to a network address. Okay. As you can see, you have 1 to 8. This one uses the first bit, and so on. Okay. Let's see. After that, you have here, you need to add for the second network again 2 to power 7. And how much would 128 plus 128 would give you 256. But this exceeds the maximum capacity that you can have for the last octet, meaning that you need to increment the previous octet. So this is why you need to increment this one. Okay, and you need to start again from 0. Okay, meaning that here the previous address needs to end in 30 and 255. Okay, as well as you need to add here again 2 to power 7. Okay, which is 128. You add it on the last octet, and here you end up in 127. Check. And okay, from 0 to 127, I do have 128 stations. Okay. And which would be the end? I would have to add again 2 to power 7, being the number of bits that I need to use for my stations. And all these bits for the stations are added at the end, meaning that I exceed again the capacity. So it's 192. Okay. Then it's 168. The next one would end. Okay, it has the start in 32. And we have 0 of mask 25. And the end of the previous network should be just before it, meaning that we need here to have 31 and 255. It's exactly the address which is before it. Okay. Do you have any questions about this part? So this is with a fixed length mask, okay? With a subnet mask. This is why you have this SM. Okay. Because these ones, they are subnets.
I have a question.
Yes.
At the beginning, you said that we have to use 23 because it.
Exactly.
Why is that?
And the 23 is here because this is the mask which is provided for your IP. It says that you have a network and you have this addressing space. So
yes.
This is the beginning of it.
Oh, so it gives it.
It
to
is
us.
by default. Yeah, exactly.
Oh, okay. Okay. I thought
So
you said something about classes, and that's why.
Yeah. So based on it, it belongs to class C, so it should be 24. But here, you will see that this mask changes according to the number of stations. You can also have it modified. So like here, you have the starting point in 23. This is the trick for it.
Okay, so the classes are not, we don't have to have slash to say 16 or something like that. We can change it.
So you need, it's based on what is given. If it doesn't give the mask, then it means that it's the default one.
Oh, okay.
If it provides it, then you need to be careful to check which one is it.
Okay, thank you.
And for it, you're welcome, you should use this table. Okay, so you have here the ranges for each IP, and based on the range, you know to which class it belongs and which would be the default mask. But when this default mask is given, you start from it. Any other questions? Okay. So you see here that for every subnet, you have in total 126 stations that you can assign. So it's 2 to the power 7 minus 2. So for 120 stations, okay, let's say that it's fine. But for 60 stations, you already have a lot of waste, 50 even more. And what about these two when, okay, for them, you have just 2 stations. So here you waste really a lot of space. So this is why you can have this variable mask. And this variable mask depends on the number of bits that you use for your stations. So it means that you start by sorting the networks according to the number of stations in decreasing order. Okay, so let's see. So you need to sort in decreasing order all the networks, okay, the stations. All right, then for each station, you need to think which are the number of bits, this p, knowing that the number of stations needs to be less than 2 to the power p minus 2, because you do not use neither the network address, neither the broadcast address, meaning that the new mask will be in fact 32 minus p. Okay, because for every IP, I have the part regarding the network. So this would be the part for the mask, saying how many bits I use for the network, and this would be my bits for the station. Okay, and the mask shows how many bits I used for the network. So let's see. All right. Okay. So here it's written again what you need to do as an algorithm for the variable length mask. So, okay, step 1 is to sort in decreasing order your stations, such that you have this 120 from here. Okay, check. Then we have 60, check. Then we have 50, which is this one. And the connection between these two routers where you need to assign the ports, okay, as before when you are forwarding packages, and this means that you have here 2 stations. Okay. So this is step 1. First, you need to add the number of stations in decreasing order. Okay. Then this number from here needs to be less or equal than 2 to the power p minus 2. And here, in fact, the unit is this p that you need to use. Okay. So it comes like this. 120 is less or equal than 2 to the power 7 minus 2. Okay, so we have 128 minus 2. It's okay. 60 is less or equal than what? You need the greatest power of 2, which is just coming after it. So being 2 to the power 6, which is 64 minus 2. Okay, is all right. Then 50 is the same. Okay, and here you need 2 because you need to subtract this one. So you have less or equal than 2 to the power p minus 2. So it means that my p needs to be 2. Clear up to this point? You need to sort your stations, you add them in decreasing order, and then I find out which is the power of this p. Okay, so the closest power of 2, okay, which is greater than the value, but you also need to subtract this 2 because you cannot use your network and either the broadcast address. Okay. Then the prefix is in fact the maximum capacity which you can have, so that in total you have 32 bits, minus my p, being the previous column. So let's see. Here I have what? I have 32 minus 7, okay, which is this 25. Then I have 32 minus 6, okay, which is 26. Again, 32 minus 6, okay. This is 32 minus 6. Okay, this is again 32 minus 6, and this 30 is in fact 32 minus this 2, so we've got 32 minus 2. Okay, so which would be the network mask? In fact, you need to think how many octets do you need to have filled. 25 means what? We have, let's say 25. This means that we have how many values of 8? We have this 8 multiplied by 3. So we have 3 filled octets, okay, which is this one. And we also need to add a 1 such that we obtain, in fact, okay, this one, 128. So this 3 times 8 means that I have this group, which is with 255 3 times. And you've got another octet, and you need to fill the leftmost octet. So remember that an octet, you have 8 positions. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Starting from 2 to power 0 until 2 to power 7. So this means 128. Okay, I have 64. Then here I have my 32. Then I have 16, 8, 4, 2, and 1. Okay, and here you have all the powers. So here you start filling the network from left to right. This means that when going from left to right, the position that I need to use for this one is in fact the first one. So this is why I have this 1 to 8 at the end. Okay, and now I need to start from the IP which is given. Okay, so this is the initial IP. Okay, and I need to add this initial IP over here, but my mask needs to be exactly the new one, which is per row, being this 25. So for the first subnet of 120 stations, I need to use the mask of 25. And I need in total 2 to power 7 stations. So I start from 0 until 127. So it means that here at the end, I need to add 2 to my power p. Okay, 2 to power p, which in fact here is equal to, I have 2 to power 7, okay, which is exactly this 128. So it means that I did reach this part. Okay, this is what is obtained. Clear up to now?
Yes.
And the others?
Yes, it's okay.
Should I go? Okay. So over here, it means that you need 26. 26 is how much? You have 8 multiplied by 3, plus you need 2 more bits. So it means that I need also the other one. So I need this one too. So 128 plus 64 gives me 192. Okay. And don't forget that the mask is the updated one. So you take the mask from here, and this mask from here exists here as well as here. Okay. Then for this one, where does it end? Well, I need to add 2 to the power p, which is 2 to the power 6, which is 64, and that gives us 192. So this means that here I need to have the previous value, which is in fact this 191. Okay. So from here, this would be the previous one. What do I need to add here on this position? 2 to the power, how much? It's my 2 to my power p, and my p is in fact 6. So I need to add 2 to the power 6. And 192 plus 64 gives me how much? It's 256, which exceeds the maximum capacity such that I have to increment the previous octet. So here I would obtain 31 and 0, while the last octet needs to end in 30 and is 255. Okay. And the mask is again the same. Here I have 25, meaning that I have this 25 here, and 25 is also reflected here. Okay. Then for 30 as a mask, it means that I should not use the last 2 octets, so neither this one, neither this one. And this means that I have the maximum capacity, which is 255, out of which I need to subtract the value for 2 and for 1. And this is why I obtained this 252. Okay. Having it in this way, and with the mask, don't forget that here it ends again in 30 and 30. You would need to use for your mask 2 to the power 2. So here you would have 2 to the power 2, meaning that it would end here at the end in 4, such that the previous address needs to end up in this 3. So you start from 0 until 3. You have, in fact, 4 stations, 2 to the power p. But the stations which can be assigned is this 2 to the power p minus 2. Namely, you can have just these 2 stations. And in this way, it's an optimized way, because as you can see, the last address is 192, 168, 31, and 3. While for the previous method, you go until 255. So you have stations that are wasted for nothing, and you can assign it to other stations, and you can also be paid for them. Okay. Now, is it clear up to now?
Yes.
So don't waste space which you can use for a certain network, because it's a pity you just waste IPs for absolutely nothing. Okay, let's have this one ending. And now you have the part of activities. So let's see. Here for your IPs which are provided, you should specify which is the class and the default mask, and thus to say whether an address is public or private. So private, they are usually the ones of corporations and secret services police. Okay, so you have the class A starting from 10.00 up to 10, and you have all the octets occupied. Then class B starts in 172.16 up to 172.13, and all the octets occupied, 31. Yes. As well as in class C, you have this 192, 168.00 until you have the octets occupied. So when having a requirement, you should see which is the address space that you will use. So if you will have to assign a private space, you need to choose an IP from this range, okay? All right, so let's see these ones. They belong to which class and mask, and whether they are public or private. I will go here and you can have them. All right, so you have class A, you have just the first octet occupied. The mask is with 8, meaning that you have 255 and then 000. And you have the range of IP starting from 1 up to the open range of 128 when you use 2 to power 7. Okay, so for every class you need to add the powers of 2, and this is how you obtain the beginning of your range. Let's see, the first one belongs to which class?
It's public and class B.
B, exactly.
Okay, yeah, it is public. Okay, it will be this B. Okay. And in this case, the mask is how much?
16 bits.
Exactly, yeah. Then we have this one with 10, 20, 40, 80. This is public or private?
Private class A/8.
Yeah, it belongs to this interval. So we have, let's say here we have the public with plus, like in Java, and this one is with minus. Then, yeah, we have A, and this is with 8. 30 would be what?
Public.
Public. Okay. Then the class is
A and /8.
yeah. Okay. The next one would belong to which interval?
Class C, it's public,
Okay.
and /24.
Perfect. Okay. Check. Clear for everybody? So you can ask whether you have any problem.
Do we write them?
After that, when uploading, yeah, you will have to write them. So, or you can do it online like me, or you do it by hand and then you just take a picture and you upload.
Okay.
Let's see for this one. Okay. So it says that we have an addressing space of 16. This means that you are in which class?
B.
B.
B, yeah. Okay. And in this case, you don't want to waste so many stations. So you have several types. When you want a maximum number of stations, okay, with a minimum value of a certain amount of stations, okay, but keep in mind it's a maximum number of networks. So this means that you need to use the number of stations, and this number of stations needs to be less or equal than 2 to power p minus 2, because I want to see how many bits I can use for my stations. And then according to the station number, okay, of bits, I can have the mask of 32 minus p, okay, because you have here the restriction based on your stations, and you want to have many networks, okay. So this is why you would use the variable mask. Then if you want to use a minimum number of networks and you can have the maximum number of stations, this means that you have the fixed length mask such that you use the number of stations. So this n is your number of stations. You need to have n less or equal than 2 to power n. You have your new number of stations such that your new mask will be the previous one, this m, which is 16. Okay, so m is 16, the given mask, plus you have the new mask, the new number of bits that you have to use for your number of stations, and for your remaining bits for the stations, you have 32 minus the mask, minus the number of bits that you need for the number of subnetworks, and you obtain the number of bits such that in total you have 2 to power p minus 2 stations. So let's see it here. Firstly, you want to have a maximum number of networks. But this means that you have the constraint based on the number of stations. Whenever you have the number of stations, so let's say that we are in this A. Okay, so we have this A. It means that 100 is less or equal, okay, than 2 to a power p minus 2. And in this case, p would be how much?
7.
Yeah, p is 7. So the new mask is 32 minus 7, being equal to 25. Clear for everyone? Okay, I hope it's clear. Then for B, I have 63 less or equal than 2 to power p minus 2. So which would be the p in this case?
Still
You
7.
cannot, yeah, you cannot use here 6 because it would be 62. So again, it's p equal to 7, meaning that the mask is again 25. Okay. Then we have the next part with C. You have minimum 10 networks, so this 10, okay, needs to be less or equal than 2 to a power n, where this n you add to your bits regarding the address space. So it means that my n is equal to how much?
4.
Exactly. So my new mask is the previous one, which is 16, okay, plus 4, the bits that I use for the network, meaning that the mask is of 20. Okay. How many bits do I have for the stations? My P. The number of bits for my stations is in fact 32 minus the address space minus the bits for the network, so it's minus 20, the mask, so it would be equal to 12. And this means that we have in total 2 to the power 12 minus 2 stations. Okay. Good for everyone?
Yes.
Okay. Here you have 256. 256 is in fact which power of 2?
8.
Yeah. So we have 2 to the power 7, which is 128. So it means here that we need to use the next power, meaning that we have n equal to 8. And the new mask will be 16 plus 8, okay, which is equal to
24.
24. So how many stations do you have? You have 2 to the power 32 minus 24. So it's 2 to the power 8 minus 2, meaning that in total you have 254 stations. Okay. Yes, stations. Okay. Any questions regarding this activity? I also paste it here. So whenever you want a minimum number of stations, you need to, and the maximum number of networks, it means that you need to choose the variable length mask. So this is why you start from the number of stations, like you were adding it in decreasing order. While for a maximum number of stations and a minimum of a certain amount of networks, you need to use the fixed length subnet mask, where everything depends on the number of subnets, and you need to add to the default addressing space the number of bits that you have for your network, as well as you need to compute how many bits you've got for the stations, being this 32 minus the mask minus the number of bits in order to have the number of subnets. Okay. All right. Let's see it here. For this activity, you will have to say which is your network and broadcast address. This means that you need to transform it in binary format, then to say which is the first and the last address, as well as to say how many stations you've got. Let's see. First of all, you have 100. 100 is the sum between what? The greatest power of 2 less than this 100 is in fact, you have 64. To 64, or what should you add? Which next power? You should add
32.
exactly, and then
4.
yeah, and we have 100. Then we have 50 as being how much?
32, 16, and 2.
Yeah, exactly. Good, thank you. Let's see. Again, as a recap, you have all the powers. So for every octet, you use the powers from 2 to the power 7 here leftmost until 2 to the power 0. So adding it, okay, this is the middle, and other 2. This is 2 to the power 0. Here we have 2 to the power 7. So this one is 128. Okay, then this is 64. Then I have 32. Then I have 16, 8, 4, 2, and 1. All right. So let's see this one based on it. Let's have it in this way. Here I have 100. So for 128 I have a 0. Then 64 is used. 32 is used. 16 is not used, so it's a 0. 8 is not used, so it's a 0. 4 is used, so it's a 1. 0 is not used. 1 is not used. Okay, and this would be my 100 from here. Then I need to represent 50. So I don't use 128. I don't use 64. I use 32. 16 is also used. Then 8 is not used, so I have a 0. 4 is not used. 2 is used. Okay, 0. Okay, this is to the power 0, which is not used. All right. And then I would simply copy it because it's again 150. So it means that I have a 0, 1, 1. Then I have a 0, 0. I have another 1, 0, 0. Then I have another 0, 0. I have 1, 1. I have a 0, 0. Okay, 1, 0. Then 24 means that I have 3 octets which are occupied, so it's up to this point, meaning that I have values of 1 from here up to this point, and the last octet is filled until the end with 0. Okay. And now you need to find out which is the network address, such that for the network address you do the logical AND between your IP and the mask, while for the broadcast address you need to do the NOR. Okay, so when doing them, you will have here for the network which value. So let's see, network. So you remain with 1 just when you have them the same. Okay, so when you have a 1 and a 1. So the value of the network would be how much?
150, 100, and 0.
Okay, exactly. 150, 100, okay, and 0. Then if I want to compute the broadcast, okay, this means that I need to invert the mask. So you start from 0, then this is in 0. I will have 1 till 1, and you need to perform the logical OR between them. Okay, such that this part influences the result, okay, being 1, 1, 1 everywhere. So let's see, the value of broadcast would be how much?
150, 100, 255.
Yeah, exactly. But then you have 50, 100, okay, and this 255. So now which would be the first address that you can assign for a station?
That one. The last one.
Exactly. It's with that 1 for the last octet. So the first station would have the IP 100, then I have 50. I have 100. Okay. And 1. Then my last station would be how much?
254.
Exactly. So it's with 254 at the end. All right. And the remaining is the same. So it is 100. Then I have 50. Okay. Again 100. Okay. So now comes the question, how many stations do you have in total? If you do the sum,
2 to power 8 minus 2.
exactly, yeah. 2 to power 8 minus 2. So even if you have the numbers from 0, I mean from 1 to 254, it means that you have in fact equal to 254 stations. Okay, yeah, good. Okay, so I will add this inside the chat. Okay. And for the rest, you should do the same. As here, you should be careful on the last one because you will have an overlapping such that you will have this fixed length mask in order to compute the number of stations. Okay, so this is what you need to continue in the same manner. Is everything clear regarding what I did show?
Clear.
So network is with logical and between the binary format of the network and the mask. For the broadcast address, you need to invert the mask and you perform the logical OR. After that, having the beginning and the end, the first address is the one following the network, such that this is why you've got the one here at the end, being the one after this one. And the last address is exactly the one which comes before your broadcast address. So this is why you have this 254. Okay. Also, you have this network. And in this network, you have an address space, which is this one. As you can see, you start from the mask, which is 19. Okay. And you have this 172, 16, 160, and 0. Now you want to waste as few addresses as possible. So which one would you use? The fixed length mask or the variable net mask?
Variable.
Yeah, you use the variable such that you will have to order in decreasing order all the stations. And then based on it, you will have to assign which would be the IP starting from the space which is provided. And keep in mind that here you also have the connections between routers, such that how many networks, I mean subnets, would you have? You have the big ones here in the edges, 1, 2, 3, 4, 5, 6, 7. So 7, and then the connections between the routers. 7, 8, 9, 10, 11, 12, and this 13. Okay, so you have the connection between one router and another because you need to assign the ports in order to connect them. Now let's have it solved. So we will have the part, okay, with this broadcast. I should make it big. Let's see. Okay. And I have this one. All right. And starting from it, I need to place in decreasing order all the stations. Let's see. Okay, I have my network, number of stations, number of bits, prefix length. I have my mask, network address, and broadcast. Okay, so we would have network 1, 2, 3, and so on. Let's see. The first one in decreasing order based on the stations. Okay, so you need to put it in decreasing order. You will have how many? Which is the maximum number?
192.
Exactly. So I have here 192. Okay. Let's put this one here. Okay. Then the following one would be so this one is used. Then which is the next one? In decreasing order for your
158.
stations. Yeah. Okay. So this one goes also. Then let's see. Which will be the next one? After 158 comes
120.
okay. Right. Followed by
59. 40.
yeah. Okay. So we have this 59. Okay, and this one disappears. Then I have this 40 here. Okay. After that would be 28, 10. So here I have 28. Then okay. So we have the main 7 station 1, 2, 3, 4, 5, 6, 7, and then I have how many connections of 2? 1, 2, 3, 4, 5, okay, and 6 based on all the lines. Because I have these connections from this one to this one, 1 to 1, here and here, so we have them 2 by 2. Again, here 1, again 1 when sending packages. So we have these ones. Okay. And from here to here. So in fact I have 1, 2, 3, 4, 5, and 6 connections where I have 2 stations. So this is 2. I need another 2. Okay. So I will have it here again 2, 2, and another 2 based on all the 6 connections. Okay. 1, 3, 4. Okay. And this would be the next 6 router connections. Okay. All right, let's see. Then the number of bits for your stations, this one needs to be okay, less or equal than 2 to power p minus 2. Okay, compared to this value. And here I have my number p. Okay, so how much would you use here?
8.
Yes. Then here, it would be again 8, because 2 to power 7 is 128. Okay. So this one means that for 120 I use which power of p?
7,
Exactly.
then 6,
Then it's
also 6.
okay. Yes.
Then it's 5,
Mm-hmm.
4,
Then it's yes.
and then should be 2.
Yeah, it should be 2 because you have this -2, so you cannot use 1. Use this 2, 2, 2 until the end. Okay, okay. Then I have my prefix. I have 32 bits minus my p, where I take p from here. So this means that over here I have 24. Okay, so this would be the mask. Okay, then I have 24, 25. Okay, I have 26 again. 26, 27, 28. Okay, this is with 30, 30. Okay, and 30 until the end. Okay. Then my network mask is, this means that you need to split it. You have 3 times 8, so you have 255 3 times and 0. Oh, so you have to write like this. 7 to 5 and again up to 55 and 0. 5, 5. Then this one is the same. This means that at the end I don't have a 0, I have a 128. Then for this one I need to add a 64. So it's 192 times and so on. Okay, which would be my network address? So well, I need to use the IP which is provided, being this one. 172, not 16. 160 and 0, where the mask is this 24. And how much do I need to add? I need to add 2 to power 8. So this means that I have 256 and I need to increment the last octet, meaning that I have this one starting in 172. That I have 16, 161. Okay, and 0 with a mask of 24. So here what I need to add is 2 to power p. So here I add 2 to power p, where my p is this 8. So this is why I add 256 and I need to increment this previous octet. And where does it end? Where is exactly the address before it? Being 172. Okay. I have 16, 160, 255, with a mask of 24. Then I need to add again the power. Okay, here I need to add 2 to power 8 to this one. So I add here 2 to power 8. It again exceeds the value because it's 256. So I need to increment the previous octet such that I have 172. Okay, but 16, 160 62 and 0, where the mask now is the one of 25, which is the previous address before it. It is the one with 172. Okay, then I have 16. Okay, I will have 161 and 255. As you can see, from 0 until 255, I have in total 2 to the power 8 stations, but I cannot assign the first and the last one for the network and the broadcast, so being 256. And here it's 255, where the mask is of 24. Okay. Then for this one, what you need to add is this 7. So it means that here you need to add 2 to the power 7. So here, as you can see, this 7 from here needs to be added for the last octet, which is this one. Okay, and let's see the value. It will be 172, 162, 128 of mask. Okay, so here we have a dot of mask 26. Okay. And this one needs to end in the previous value, which is 128. So it's again 172 16 or 162 127. Okay, so this is a 7 of mask 25. Okay. For this one, I add again this value. So this one needs to be added, and it needs to be added here. So I will add plus 2 to the power 6, which is 64, so I obtain 192. 192 of mask 26. Okay, and let's add this one. 2. Then it's a 16. 6, 2. Okay, so we end up in 191. 172. This is the one with 16. 6, 2. 191 of mask 26. Okay, and to this one. I need to add it here. So this 6 comes at the end. 192 plus 64 means 256. So I need to increment the third octet. So this means plus 2 to the power 6. And I need to increment this last octet because I have exceeded the capacity. So it means that I have 172, not 16, 163, that 0 of mask 27. And the previous value will end in 255. So it's 172. Dot 16. Dot 162. Dot 255. Okay. And this mask is based on the line of 26. Then based on this one, I need to add 2 to the power 5. 2 to the power 5 is added here. Okay, and 2 to the power 5 is 32. So it is this 172. Not 16. Not 163. And then I add this 2 to the power 5. Okay, being 32. Okay, so this is with this plus 2 to the power 5. Okay, and our mask is of 28, meaning that this one here ends in 172.16.163.31. And as you can see, from 0 until 31, you have 32 numbers, and in fact, you have 30 stations. So this is with 27. And let's see what we add here. It means that we have to add this 4. Okay, let's put it blue as before. So this one here goes at the end. And we need to add 16. So it's plus 2 to the power 4. So 16 will be 48. Okay, let's see. 2, 16, 163. Okay, and we have 32. You add to the power 4 is 16, so it's 48. Where we have the mask, this one of 30. So this means that here we end in 47 with a mask of 28. 7, okay, 28. And we have in front 172. 16. 163. Okay. As well as we have these 2. We add 2 at the end, so we add a 4. And we reach 52. So you add 2 to the power 2 here. Okay. So this one ends in 52. Okay, you maintain it. So it will be with 30. And now you see that this one is, so the first 3 octets are the same. And this one being with 52, because we have 48 plus 52. This is with 51. Such that you have 2 stations. The first address which you can assign ends in 49, and the next one will be with 50, and thus the mask is of 30. And you would continue like this. You have here 62, you add the 4, this is 56, you end in 5, and so on, keeping the mask of 30. So you have to finish this whole table. Do you have any question up to now? So when having here 0 with 161, this is the address which comes before. So it means that it ends in 160 and 255 and so on. So in fact, it is like Z and you read it like this, okay? So this one begins here, ends here, you have another start and so on. So the one which is here is in fact this one to which you apply a -1, okay? Is your next network address. And this network address is obtained by adding your 2 to power p for the last octet. Like here you add in fact 2 to power 8, okay, and this 2 to power 8 means a maximum capacity, and this is why you have this one 161, which again you need to add another 2 to power 8 and you reach 162, to which you need to add 2 to power 7, which is 128, meaning that the one being here, it has this -1. So as you can see, you add 2 to power p, and here in fact you have the address, but you maintain the mask, and you have this -1, okay, being the previous one. Okay. And this is how you find out which is the network and the broadcast address. Keeping in mind that for every connection between two routers, you have a subnet of 2 stations. And when choosing this prefix and the number of bits, you have this -2. So you don't use the network and the broadcast address. Do you have any questions for this exercise? Because for your homework, you will have something similar. You don't have the drawing, you have the description with the networks which you've got, how many networks they are, and whenever you have these subnets, you need to connect them based on routers. So it's exactly like here, such that you need to design how your network would look like with all the subnets, and then you need to answer to all those questions, okay? So which would be the class of the address space which is received, like is this one, okay? So you would have them one by one. And keep in mind that this is your default mask, okay? So these are the questions which you should answer. And you should do it by hand, okay? So everyone to write and design the whole network and then compute everything. Let's see, any questions regarding the last exercise? I will paste it, not to forget about
Can I ask
sharing it.
something?
Yes.
The IP address, how we increased it? Like
So
116, and after that 161, 162.
so
I
this,
understand the
yeah.
broadcast.
So it is based on how many IP, I mean, how many
How
bits you
how
use
we increase
for
this?
the stations.
Yes.
So you start increasing from the last octet, and it all depends on the number of stations which you've got. So first you have to add all the stations according to the subnets in decreasing order. So let's say, okay, here we start from 192, and which is the power of 2 that is greater than it, okay, exactly the following power that is greater would be this 2 to power 8. How much is 2 to power 8? 2 to power 8 is 256.
250. Yes.
Yeah. And which is the maximum capacity of an octet? an octet belongs to the interval which is 0 and 255.
55.
So in total, you have 256 values. Okay. But when adding this 2 to power 8 to be 256 for 0, it means that I need to increase the previous octet. So this is why you reach 161. Yeah.
Yes, yes.
Because you cannot have 256 at the end.
Yes, yes.
Okay. Any other questions? So I will also add the updated version. Okay. And don't forget that you maintain the mask. So the mask obtained according to the number of bits which you need to use for the number of stations need to be assigned for each and every IP. For the network, for the broadcast, as well as the stations which you've got in the network. So even here, if I end up with 0, and I need to add 2 to power 8, it's again, I have 0 plus 2 to power 8 is 256. I cannot put that 256 because it exceeds the maximum capacity, meaning that I have 162. And here, when I have to add 2 to power 7 and the result is put underneath, it means that 0 plus 2 to power 7, that's 128. So you have this one. And the broadcast of the previous address needs to be the one before, so it ends in 127. And in total, you have 128 values because you have from 0 until 127. So you have them all. Okay. Clear for everyone? So you can ask questions even after the lab if you have any problems while solving. I will stop the recording.